Okay, so today we are talking about similar triangles. Yesterday we talked about similar polygons. And we said in order for polygons to be similar, all the corresponding angles have to be congruent and all the corresponding sides have to be proportional. And that's true of triangles as well. But just like when we talked about congruent triangles, there were shortcuts of ways to prove that they were congruent. There's also shortcuts in ways to prove triangles similar. And we're going to talk about 3 of those today. The first one is the angle-angle similarity, and basically, if you can show that triangles have 2 pairs of angles congruent, then that's enough to prove that the triangles are similar. And so you can see here that angle P and angle S are congruent, and angle R and angle U are congruent, so that's enough information to say, yes, these triangles are congruent, and it's by the angle-angle similarity. And this is what you would use as your abbreviation. Make sure you put the little similar symbol right there. Alright, so here's a couple of problems. Determine whether the triangles are similar. If so, write a similarity statement. Explain your reasoning. If I look at these 2 triangles here, I've got angle L, which is 57 degrees, and angle K, which is 48. I need to find angle J, right? We know that the sum of all the angles is 180. So if I add those together and subtract from 180, I get angle J is 75 degrees. Well, if I then compare, that doesn't look very good there. If I then compare this to the other triangle, I have a pair of 75-degree angles, and I have a pair of 57-degree angles. Is that enough to prove the triangle is similar? Yes, by angle-angle. So it says write a similarity statement. And so if I say triangle JKL is similar to, how would I write the other triangle? QPN, that's correct. Because if I go 75, 48, 57, I have to go 75 degrees, 48 degrees, 57 degrees. Okay, so I have to go in the same order. Alright, and this is by the angle-angle similarity. Alright, so let's look at this next one. We've got a pair of triangles here. We want to determine if these are similar. What can we tell about these 2 triangles? Okay, we've got parallel lines, and they're cut by 2 different transversals, right? We've got some vertical angles that are congruent. What can I get with the parallel lines, though? Yes, alternate interior angles. So these 2 angles are congruent, as well as the other 2, right? But just the 2 angles is sufficient enough information to show that the triangles are similar. So I could say that triangle RSX is similar to, how would I state the other one? WST, because the W and the R correspond. So WST. And my reason would be, again, by the angle-angle similarity. Alright, so that's the first way that we can prove triangles similar, angle-angle similarity. Another way is by the side-side-side similarity. And it says that if the corresponding side lengths of 2 triangles are proportional, then the triangles are similar. So all we have to do is show all 3 pairs of sides proportional. So it would be like showing A is to AX, as B is to BX, as C is to CX. Okay? Basically, if you were to write them as a fraction, they all have the same ratio, okay? Or the same scale factor. You need to be able to identify how you would do that by stating the actual segments. So, like JL is to MQ, as JK is to MP, as LK is to QP. So if I can show all 3 pairs of sides proportional, then that's sufficient enough information to prove the triangle is similar. Then the last way is the side-angle-side similarity. And in this one, if I can show 2 pairs of sides proportional, and then the angle sandwiched in between those 2 sides congruent, that's enough information. So again, A is to AX, as B is to BX. Those are my proportional sides. And then see how angle S and angle Y is sandwiched in between those proportional sides? If I can show them congruent, then the triangles are similar. So we have to show that SR is to YX, as ST is to YZ, and angle S congruent to angle Y. And again, that angle has to be sandwiched in between those proportional sides. Everybody got that? couple of examples. It says determine whether the triangles are similar, explain your reasoning. Now, this first one really has two potential ways. What do you think? They give us information about what? Huh? All the sides, right? So I could test what? I could test side, side, side. So I now need to kind of look and see what I want to coordinate with what. What do you think A would correspond with? The 20? 8 is to 20 as what? 5 is to 12.5 as 6 is to 15. Okay? So if I divide each one of those out, 8 divided by 20 is 0.4, 5 divided by 12.5 is 0.4, and 6 divided by 15 is going to be 0.4. So, are these sides proportional? Yes. Okay, so I can say that triangle PQR is similar to triangle what? STR. And that is by the side, side, side similarity. Now, could I have done that one in a different way? What else could I have done? I could have done side angle side because I got the vertical angles here, right? So really, that one could have been done two different ways. Okay, here's another one. Do I have two triangles? Yes. I have this little guy right here, right? And then I have the big one, right? Okay. Might be helpful to move this big one over. And this is triangle CAB. And let's see, if you add these two together, this side is 12. Add these together, this side is 15. I don't know anything about the bottom. But now I'm going to compare the blue and the green triangle. What am I testing for? Which one am I going for, you think?
Side angle side.
Side angle side. What's my angle? Angle A. How do I know about angle? What do I know about angle A? They share it. It's the same one, okay? And so then I need to look at the sides that sandwich those that angle A, right? So I can test 8 is to 12 as 10 is to 15. And if I cross multiply here, that's one way to test it. 120 equals 120. So are those sides proportional? Yes. If I reduce both of them, they would both reduce to be, what, 2/3? So that's another way that you could have tested it. All right, so then we know that the triangle EAF is similar to triangle, how would I name the second one? CAB. And it is by the side angle side similarity. Questions on that before we go on? Okay, on your next one. All right, one correction you need to make here. For some reason, my tools are messing up. This should be triangle. Yours is okay. It's similar to, but yours needs to read BDC. I've got it, I think, transposed. So change that up there on that example to BDC. This is a good EOI question, or even an ACT question. It says in the figure, angle ADB is a right angle. Which of the following would not be sufficient to prove that this triangle ADB similar to triangle BDC? Now, one thing I'm going to do here is I'm going to separate these triangles, and I want to orient them to be the same. That makes it a little bit easier to see what's going on. So I've got this triangle here, ABD, and I've got a right angle there. And then I'm looking at this other triangle, BDC. And so I've got to rotate it to the left. And my B is here, this is my D, and this is my C. And I want to determine if these two triangles are similar. And three of these ways will prove them similar. One of them will not. Okay, so I have a right angle in both of these. And then this one says AD is to BD, A is to AX, as BD is to CD, B is to BX. Is that enough information to prove the triangle's congruent? Yes, by what? SAS. Okay. So that one is okay. Alright. Alright. Now the next one, let's see. ABD is congruent to angle C. ABD is congruent to angle C. Is that enough information to prove the triangle's similar? Well, I've got a right angle, and then I've got a pair of congruent angles. So yes, by what? Angle, angle, right? Okay. So that one's good. Let's look at this next one. AB is to BC. A is to AX. As BD is to CD. B is to BX. Is that enough information to put the triangles similar? What's wrong with it? The angle is not sandwiched in between those two sides, okay? So this one right here is not sufficient enough information. This one would have proved SSS, okay? But again, you've got to check and make sure that the sides are jiving when you do it, okay? All right. The next thing is the similarity of triangles is reflexive, symmetric, and transitive. You remember we talked about those in respect to congruent angles, congruent sides, congruent triangles. It also works with similar triangles. So we can use those three properties with similar triangles. So if you said triangle ABC is similar to triangle DEF, then you could flip it and say triangle DEF is similar to triangle ABC. That's a symmetric property. Okay. So those all three of those work with that. All right, a couple more examples here. In the figure, FG is congruent to EG, and I have that marked. And then it gives us some values for the sides. It wants us to determine which triangles in the figure are similar. Now, what does this tell me if these two sides here are congruent? What can I get from that? It's isosceles, which means these two base angles are congruent, right? So more than likely, looking at the values they gave me, these are probably not isosceles triangles, and so I'm probably going to look to see if I can prove these similar, okay? So the first thing I'm going to do is I'm going to separate them into two separate triangles, okay? So, and this is A, B, E here, and then I'm going to make this one over here, which is F, C, D. And I know that F and E are congruent to each other. And then it gives me some values here. But one thing I notice is that one of them is a reflected version of the other. So in order for me to determine this, sometimes I find it helpful to orient the two triangles to be the same. So I'm going to take this one, I'm going to reflect it, put it down below here, and then I'm going to label it. So this is going to be C, D, F, and these two are congruent. So now, it's the same triangle I've just reflected. I'm looking at this right here, okay? It tells me that BE is 15. It tells me that CF is 20. And it tells me that AE is 9. And DF is 12. All right. So what am I looking at to determine if these are similar? What am I going for here? SAS, right? And I heard somebody say, okay, 15 is to 20 as 9 is to 12. And both of those reduce to be 3/4, right? Okay? Or if you divide them out, it would be 0.75. Or you can cross multiply and they would both be 1/8. However you looked at it, they are proportional. So these are the two triangles that are similar. Okay? So we would say that triangle ABE is similar to, how would we state the other one? DCF. And it's by the side angle side similarity. Do you see how taking and separating the triangles and then orienting them to be the same, how that's helpful sometimes? I mean, some of you are okay to do it all in your head, but sometimes you got to work at it the other way and get good at it before you can start doing it in your head, okay? All right, here's another one. In this one, we want to find BE, which is my X, and then I want to find AD, which is Y plus 3. So I got to find Y and then add 3 to it. But before I can start setting up equations or proportions or anything like that, I need to look to see if there's a relationship going on here. What kind of relationship do these triangles have, or are there any triangles? There's one I see. Is There's really two, right? So what do I need to look at here? The triangles are obviously not congruent, right? Are they similar? Possibly. We've got a triangle right here, right? They do share an angle, you're right. And we've got a triangle here. They do share this little angle right here, you're right. It gives us some information here about these two lines. It says that they're parallel. What can I get from that? What happens when you have parallel lines cut by a transversal? Alternate interior angles, yes. What else? Consecutive angles or something. Corresponding angles. Corresponding. Aren't these corresponding right here?
Yes.
Okay, so these angles right here are going to be congruent, right? So is that enough information to show that the red triangle is similar to the blue?
Yes.
Yes. Okay. So now I'm going to redraw this. And this is A, B, E. This is 3. This is X. This is Y. Here is my blue one. This is A, C, D. This is 5. This is 3.5. And this is Y plus 3. Okay, so these two triangles are similar, right? I've just redrawn them. I've separated them. Okay? How would I determine what X is? Right, we can just set up a proportion. So 3 is to 5 as X is to 3.5. And so we cross multiply, and we end up with 10.5 equals 5X. We divide both sides by 5, and we get X is 2.1. Okay, and that is also my BE. Okay, what about Y? Got to set up a proportion again. Okay, how am I going to set it up? 3 is to 5. Y is to Y plus 3, right? So again, we cross multiply. We end up with 3Y plus 9 equals 5Y. We're going to subtract 3Y from both sides, so we get 9 equals 2Y, and so Y is 4.5. But I need AD, right? AE is 4.5, but AD, what do you have to do? Add 3 to it. So it's going to be 4.5 plus 3, which is 7.5. All right, we've got one more here. Everybody got that written down? Yes? Okay. Last one. Hallie is estimating the height of the Superman roller coaster in Mitchville, Maryland. She is 5 feet 3 inches tall, and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? Okay, so we have Hallie right here. Okay, and she is 5 feet 3 inches tall, and her shadow that she casts is 3 feet. All right, then we have. I'm going to redraw this. I'm going to scoot it up just a second. Okay, same idea. I'm just going to draw them a little bit better. So this is 5 feet 3 inches. This is 3 feet. I didn't do a very good job. I did it again. Okay, it says that the shadow of the roller coaster is 40 feet, and I want to know the height of the roller coaster. Okay? Now, I'm kind of prefacing this so you understand why this works this way. Obviously, these parts are proportional. At least they look like they are, right? And the reason they are is because we've got the sun here that's shining down, right? And it shines down and it creates these rays. Okay? And the rays are parallel to each other. And the ground acts like a transversal. And so these two angles here are congruent. Okay? These two angles right here. So these two triangles are similar. And so the parts are proportional. Okay? So I can set up a proportion to figure out how tall the roller coaster is. What is 5 feet 3 inches? Her height. But what is it? I'm not gonna put 5 foot 3 inches into my equation. It's 5.25 because 3 inches is 3 out of 12, which is a fourth, and a fourth is 0.25, right? Okay, so I'm going to do 5.25 is to the height of the roller coaster, which is x, and then the shadows correspond, 3 is to 40. So I cross multiply, and I get 210 equals 3x. Divide both sides by 3, and x is 7 feet. Now, somebody in one of my other classes said, well, could I have done 5.25 is to 3 as x is to 40? Could you have done that? Yeah, because you're doing height to shadow, and that would work too because they're proportional. Okay, so either way that you do. All right, so we learned 3 ways to prove the triangle is similar. What were the 3 ways? SSS, that's all the sides proportional. Angle, angle, 2 angles congruent, or SAS, 2 sides proportional, and then the angle sandwiched in between congruent, right? Okay. Your assignment is on page 483.